So far we did a thorough review on inheritance, polymorphism, dynamic binding, typecasting, polymorphic collection, and generics. So now we are ready to move on to a new design pattern, which is called a state design pattern. As usual, we should really know about what a motivating problem is to really apply this particular design pattern. And then before we devise the ultimate solution for this design pattern, we would like to know about what are the alternative solutions, what are the pros and cons for those solutions. So that's something we would like to focus on for this entire lecture. So let's see what the learning objectives are. Number one, we want to learn about the motivating problem, and for the state design pattern specifically, we want to know how to solve problems for interactive systems, meaning that they never terminate the system, but they actually instead they try to interact with the user indefinitely as long as it's necessary for the user to make their requests and get their responses. Number two, we'll talk about some design attempt. Number one, we want to see how you can solve this particular problem using the assembly style, meaning that you can use an assembly language using the go-to labels, pretty much like what you learned in 2021, the computer architecture course. And design attempt number two, let's say you don't really have a OO language available to you, like a Java, IFO, C#, or even Python. Let's say you only got a language called like a C. How can you actually solve this interactive system problem using a hierarchical, non-OO, and procedural style? So that's something we'd like to talk about, and also against several design principles that we have talked about so far as well. Okay, number four, we'll talk about the ultimate solution using OO, given that we got this language available. And we want to talk about how polymorphism really play a very crucial role in making this pattern to work. So when we talk about state design pattern, but inside there's really a sub-pattern called the template design pattern that we want to learn about as well. So both of these patterns here will actually exploit polymorphism and dynamic binding, and also polymorphic collection very thoroughly. So that's something that's why we did a thorough review previously, but now you should be ready to learn about these patterns. Okay, first of all, let's talk about the motivating problem for this pattern here. So let's consider the reservation panel of an online booking system. If you click on the link, you will be redirected to this particular website over here, which is basically just a reservation website for flight tickets. So take a look. So this is kind of like an initial state of your interactive system. So you can fill in some required information over here. So maybe to say what's the departure city, and what's the destination city, and what's the departure date, and what's the return dates. So once you fill in the information, you're going to say, I want to confirm. And then once you say you confirm, you're going to be redirected to just another web page. You can think about it simply just you being transitioned to another state of the interactive system, and so on. So there might be many hidden states that's already defined by the server side, in which case for you as a client, you will simply just have to navigate through the system using whatever prompts you're given over here, either by entering some input of your credit card, for example, or your membership number. And then eventually, once you make your payments, and to confirm your reservation, you will be able to exit from the interaction with the system. So that's a very typical interaction pattern that you actually perform with such system. Okay. But for the purpose of this particular lecture over here, we cannot really consider a realistic system, but we're trying to simplify that just for illustration purpose, so you can see the pattern. So we're going to consider a very similar, a system of a very similar nature, but just much more simplified. So we talk about some also flight reservation system, and then you can still enter departure city, you can enter the dates for departure and return, and also let's say we're simply doing some command line application, meaning that over here for every state or for every page, you can choose as to which option you would like to opt for. In which case, you can say you can type 0 and enter, and then you exit from this particular site. And then you can say can type 1, and then enter is going to give you the helper, like a helper menu. And similarly, if you type 2 and also enter, is going to give you some opportunity for further inquiry, and etc. Okay, so that's about the interactive system that we are dealing with. I'll give you more examples in a moment. So let's think about, I already gave you the hints about what's really the best way to formulate such problem over here. Basically, you talk about states. You can think about individual web pages are simply like a states, and also going from one page to another is like making a transition from one state to another. So now, how do we characterize the interactive system, or how do we formulate such interactive system? So we do a set of states and also their corresponding transitions. Okay, so that's really important. And when I say applicable transitions, meaning that it's really like an NFA. Those of you who took 2001, meaning that from every state, it's not necessarily that every possible transition will be applicable. We will see some example in a moment. Okay, so the above reservation system, the flight reservation system, you can think about it has the following finite state machine. Okay, so I think I might just say state machine for short, but when we say finite, it simply means you got a finite number of states. And think about this, let's make some connection to your previous data structure course. Think about this is simply just a graph, where you know where exactly the user's interaction will start with. Okay, let's look a little bit deeper into this diagram over here. Okay, so the same diagram with just a little bit more information. Let's go over the necessary details for you. First of all, you can see we have to indicate where the start state is, which means whenever the user wants to initiate an interaction with the system, so this will be the starting point. So like initial. And then, for now, let's assume we got only 3 possible actions for every possible state, either 1 or 2 or 3. So these are all the range of possible actions the user can actually perform. However, you can see in some states, not necessarily every action will be applicable. So that's what I meant by applicable from the previous slide. So let's say, for example, you can see if we are initially in this particular state, you can see either we can choose option 1 and then we go to this state, or we can choose maybe option 2. In that case, we go to this state. Or we can choose option 3 and then we go to states. In this particular state, for initial, we also call that state number 1. All the options are applicable. On the other hand, let's say we are now in this particular state. Are all the actions applicable? Not really, because you don't see any definition for transition number 1. So you can see either we can take number from here, either we can take number 2, in which case we'll go to this particular state. It's outgoing transition. Or we can actually take transition number 3, in which case we'll go to another state. But you don't see any, you don't see the action 1. Okay, so that's the point I would like to make. So we got different states. We got initial states. We got final, meaning that we are done with the interaction. And we got flight inquiry. We got seat inquiry. Also, we got reservation. And also we got confirmation. As you can see, we don't really have any other states like maybe credit card payments or maybe a membership inquiry states realistically. But that's okay. It's just only for illustration purpose for the lecture. Okay. So that's about a state transition diagram. You may actually want to just get yourself more familiar with all the states and transitions, because we'll use this as a running example as we explain the different alternative solutions and also the ultimate solution. One more points I would like to make. So this is abstractly the state transition diagram, which is how you would like to sketch or to sketch the formulation of your system. However, when you gradually move towards the ultimate design or implementation, you will need some data structure. Okay, so this transition table is actually closer to the ultimate design or implementation. Let's just go over that very quickly. So this table over here is exactly equivalent to this diagram over here, but let's see why. So the convention is we got individual rows over here. Each row simply just correspond to a state. So you can see we got 1, 2, 3, 4, 5, 6. We got 6 states over here. That's why we got 6 rows in the table. And then for every state, it is possible, potentially possible, but may not be applicable. You may have 3 possible actions, either 1 or 2 or 3. Okay, let's just take one state for example. Let's say for state number 2, you can see either we can take action 2 or we can take action 3, right? So that's why if you go to row number 2, so this corresponds to state number 2. And then you can either take action 2 or action 3. In which case, if you take action 2, it's actually going to go to state number 1. So that's why you see state number 1 over here. Or you can actually take action number 3, in which case it's going to go to state number 3. You can see it's going to state number 3 over here. What about action number 1? In this case, it's simply not applicable. So that means we simply just can you think about conceptually? It's like a storing void or storing null, or simply store some -1, some default value basically. Okay, so this is something you want to keep in mind. All right, so that's about the correspondence between the state transition table and also the state transition diagram. You would like to really convince yourself that this one here is accurately representing whatever information you have in this formulation over here. Okay, that's something you would like to make sure yourself. All right, so let's now move back to the slides and see what a challenge might be for having such formulation. Okay, what's the design challenges? So the state transition graph may be very large and also sophisticated. When I say large, so currently we only got 6 different states over here, but potentially for a realistic system, you might have maybe more than thousands of states basically, right? In that case, it would be very large in terms of the state space and also very sophisticated. So what do I really mean by sophisticated? So let's say if you got n states, right? So now potentially how many transitions can you have based on what you learned from the data structure course? Okay, hopefully you thought about it. The answer is you can get up to n squared transitions, right? So now in this particular case, it's actually a simpler case. It's simply not it simply doesn't really reach that polynomial, that n squared complexity. For example, you can see from state number 1 to be the most complicated case, state number 1 may have some transition go to 2, may have some transition go to 3, and go to 4, go to 5, and go to 6. And similarly for state transition state number 2, you might also go to 1, go to 3, go to 4, go to 5, and go to 6. Or it may even come back over here. But it's not the case now. I'm just saying in the worst case, the most complicated system you might have would be n squared with respect to the number of states you have. Okay, just keep that in mind. So that's why we know that in the worst case, it would be very complicated. So that's why when you put a design, you want to be careful. Let me just give you a little bit more idea about what kind of concerns you want to be able to address in your ultimate solution. So the graph structure is also subject to extensions and modification. For example, you may want to add a new states, or maybe you want to collapse maybe several states into one single state for whatever requirements change that might occur on the client side. So let's say, for example, let me give you 2 examples. Let's say maybe you decide you want to merge these 2 states together, state number 2 and state number 3. Okay, let's see how we can do it, right? So basically what we try to do is, let's say for these 2 states, we no longer want them to be 2 separate states. We want to merge them. So how would you do it? So conceptually, what you really want to do is basically like this. Conceptually, you want to merge these 2, let's say, into a single state, let's say. But how do you achieve that? Well, programmatically, what you have to do maybe is to say, number 1, I want to simply get rid of state number 3, number 1. Right? Well, I will remove that state from my state space. And also, I want to remove also these 2 transitions over here. And after that, I also need to create new transition that will actually go from here into this particular state, right? Of course, I also need to delete these 2 states as well. So you have to take care of all the bookkeeping on the programming side. And also, to be more precise, how would you update this particular state transition table, right? So now in that case, you're going to remove state number 3. You're going to remove this particular row over here. And also you want to make sure every mention about state number 3 should be also removed as well. So you may also want to remove this, right? Okay, assuming that you're going to use a matrix to implement your system, but just to give you some idea. So that's about removing states. Let's take a look at another possibility. Okay, another possibility would be, let's say you want to add a new state, let's say dietary requirements. For example, let's go back to the diagram over here. Let's say between reservation and also confirmation, before you confirm, maybe the airline company would like to ask, well, what's your dietary requirements? In that case, you may want to add another state over here, for example. So maybe call it dietary requirements. And now once you get an intermediate state, maybe you will have to, I don't know, maybe you have to delete these two transitions, and then you have to make sure you have some new transition over here and have some new transition over here, right? So however the new graph structure should look like, that's really up to your requirements, in which case you have to implement. And also, of course, you have to adding a new row, maybe call that number 7, so that'll be dietary requirements, and then you have to fill in all the blanks over here yourself, right? Okay, so just to give you some idea, what will be the complexity of updating your system? Okay, so whenever you will think about design, always think about modification and extension to see if your current design is really fragile to changes. If making a change would simply mean that you actually will violate some design principle, which we'll see in some later attempt. In that case, that means making changes will actually violate design principle. That means your design is poor. Okay, that's something we'd like to show to you later before we see the ultimate solution. Okay, so now that's about the two possible changes. So what will be the general solutions requirements? We really want a general solution for such interactive system. So let me just give you the ultimate application later if you want to build for your self-interest. For example, these are the 3 possible systems. Let me just show to you. If you click on each of the hyperlink, it will be linked to the system. So one would be, for example, Taobao is a very large-scale shopping system there. So you can see, you can do search, you can choose different items over here, and also eBay. Okay, so maybe many of you have used it already. So you get a similar structure over here. You just got different web pages like different states, and also you got different ways to navigate to different other states, other pages like a transition. And finally, you can also see Amazon. Amazon is also very heavily used. So you can also try to build your own system using the design pattern that we're going to talk about in this lecture. All right, so let's now move back to the slides. In this part of the lecture, we spoke about the motivating problem for interactive systems. And the way to solve it is by first formulating the system as a finite state machine, where you got states and also the relationship between the states as transitions. And of course, you can also develop the transition table that's going to facilitate your further, your subsequent design and also implementation. And we also show you the realistic system that you can potentially build. You can take a look to maybe give you more ideas about your own projects. And for the rest of the lecture, we'll now talk about 3 possible design solutions and criticize on each one of them.